clear. I'm going to start with the first presentation, which is going to be very fundamental, going to be very easy to understand on how can we use IFTTT for your projects. That's all. Because I'm going to show you how I'm going to use this in future. The cars, automobiles, when they catch fire, we detect it, right? We get the fire detected very clearly these days. How do we do it? I am going to show you a sample. I'm going to show you how fire detection can be done, how IFTTT can be used, and all these are going to be very nice. I spent a lot of time in getting this done. So I request you to listen to it carefully, and wherever you need help, I'm there to help you. Let's go ahead and let's start it.
The listener will get a clear idea about what is IFTTT, what is IFTTT applet and its uses, how to create IFTTT applets, and finally, how to control an LED using Google Assistant and Node MCU. Introduction to IFTTT. What is IFTTT? IFTTT is the acronym for if, this, then, that, which is a web service created to chain up any two web services of your choice. We are going to deal much more about this service in the later part of the session, and we can get to know more about how this can be related to IoT. If, this, then, that. It could sound very odd to listen, but the name is very apt. If, this, then, that is all about the trigger and the action. In short, IFTTT monitors for a trigger given in this tab, and if it gets a trigger, then the action defined in that tab will be performed. So it is all about this and then that. That's why the name is very apt. How is IFTTT different? This unique web service offers many interesting options to perform with the uploaded cloud data, whereas cloud computing services, Adafruit, can only store or process the data. I mean, when you just have cloud, you can just process or store the data, but we can do more with IFTTT. IFTTT is not only processing the data, but it can also trigger other conventional services like Google Assistant, Facebook, Twitter, and any mail service which is supported by them. Let us assume that you need to send an email to your account about an event or switch on a light without even opening your browser, or you want to do it just with a voice command over Google Assistant. IFTTT makes all this possible very easily without need for any coding, and with simple user interface you can do this. Everything works better when they are together. IFTTT offers very adaptable interface to create applets. To create an account or to sign in into their account, please visit the website https://ifttt.com. As already conveyed, everything works better together. It's all about bringing services together with IFTTT. In this step, we shall discuss getting started with the IFTTT applet creation. You just need a browser, internet connection to create applets and to link any two services which you like. Click on Create tab as shown in the figure right in front of you. This will direct you to the page which gives you access to create applets. The user interface is very creative and very simple with intuitive feel that will enable everyone to understand the exact functioning of IFTTT with ease. User interface is in detail discussed in the couple of slides which are going to come after this. In this section, we will use the IFTTT service to control the on and off of an LED using Google Assistant. For controlling an LED using one applet, we need an upgraded IFTTT account or IFTTT Pro account. But as we are using free account, we will be creating two applets. One for switching on the LED and other for switching off the LED. Also, remember that at the max, we can create maximum of 3 applets for free in IFTTT account. If you want to create more applets, you have to upgrade your account to the next level. Please note that in this session, we are only showing the controlling an LED using Google Assistant. In the IFTTT, Apple Siri, Samsung Bixby are not available, but Amazon Alexa is available. If you want to control the LED using Alexa, the same can be followed and the procedure remains consistent. Creation of a trigger, that is this. The first step in creating applet is to create a trigger. In IFTTT, this stands for triggering action. Let's create a trigger with Google Assistant to do that, I mean the action, when you speak a phrase. Once you click this tab, it asks you to choose a service, then type Google Assistant as shown below. And then click the Google Assistant icon to create a trigger. This is very easy to use and very intuitive to practice as well. Click on Say a Simple Phrase tab to create a customized voice command trigger. Once it is clicked, IFTTT asks you to fill the details of the command for which the Google Assistant must respond. After filling this, click Create Trigger. The same details have been presented to you in front, where you can see that what do you want to say is filled with switch on LED. What's another way to say it is light up LED. Any other way on LED, and the response should be given by the Google Assistant as switching on LED. The language preferred is English, and there are 4 options to choose a trigger, and we go with the simplest one, say a simple phrase. Creation of feed. Before implementing that action, that is the action, you need to create a feed in Adafruit which will be linked to the Google Assistant through IFTTT. Creation of feed in the Adafruit is explained clearly in the previous session. You have to create a feed named LED following the similar procedure. The description for the feed is optional, and we encourage you to still give that. And you can see that the feed LED is created just following the same procedure as we did in the previous session. After creating the LED feed in the Adafruit, again come back to the IFTTT and click the plus symbol before that to create action. You can see that there is a plus symbol before that is highlighted. Search for Adafruit in the Choose Service field and select it. Once Adafruit is clicked, it must be connected to your account. Click on Connect. The IFTTT applet lists all the feed names available within your Adafruit account. We have got 2 feeds there. One is LED and another one is PAR data. Likewise, how many ever feeds are available, it will be displayed clearly for your reference. From the drop-down, select the LED feed name and type 1 in the field data to save. Click on Create Action button to create action. Now, this is what we are calling as the action. We are creating that. The action is created. The feed name is LED and the data to save is 1, and that's completed in this task. Visualizing Adafruit data. While creating the trigger, that is this, Google Assistant will ask the Google account to be used. So after creating the action, open the mobile phone in which the same Google account is logged in. Open the Google Assistant and tell the command you have given in the trigger. Then it replies with the comment that you have already provided. Now we need to cross check whether the data is sent to Adafruit or not. So open the Adafruit feed that you have given during the applet creation, and the value 1 must be updated as shown in the figure. You could see that the value 1 is updated. Creation of the second applet. After creating the first applet, similarly create a second applet. But the second applet for switching off the LED is very important, and we cannot do the same with one applet. We need to create 2 applets as we have not got the paid version and we are going only with the free version. So let's go ahead and we can create one more applet which is going to help us in switching off the LED. What do you want to say has to be filled with switch off LED? Any other way to say is light off LED, and another way is off LED. And in turn, the Google Assistant will tell you switching off LED and the language is retained as English. And we need to send data to Adafruit IO, and there we need to make sure that we are sending the data properly to the feed LED, and it's mentioned there, and the data to be saved is 0. Now, creating action will complete the process, and when you say switch off LED, the Google Assistant will tell you switching off LED and the data 0 will be updated. You can see the same from the Adafruit feed which is presented in front of you. Now we can successfully send data to Adafruit with just a customized voice command from Google Assistant. But the data is just lying around in the cloud. So let us use the data to make some simple IoT application. We will be using a Node MCU to subscribe data from Adafruit and to do some processing, and will control the LED. Make the following connections as we have shown in front of you. It's a very simple connection. D5 of the node MCU should be connected to pin 1 of resistor. Ground of node MCU should go to LED's negative and the positive pin of LED should go to pin 2. That's it. It's very simple and we are going to use the same setup for getting the IoT based application built. Please note that usage of resistor is not compulsory but is preferred to protect LED from getting damaged. The code. As we have learned to push publish data to Adafruit Cloud in the previous session, this session teaches about subscribing and reading data from the Adafruit Cloud. The entire process of initializing the Wi-Fi access credentials and cloud credentials remain the same as mentioned in the previous session. LED is connected to the D5 of node MCU, so a variable named LED is defined for controlling the LED. The read data from the cloud is stored in the receive data variable. RECV underscore data is the variable which is going to get the data stored from the cloud. The entire code for connecting the Wi-Fi and connecting to MQTT remains the same. The baud rate chosen is 115200. The feed name should be changed as LED in Adafruit underscore MQTT underscore subscribe. This is very important point to be noted. Include a line called as MQTT.subscribe and in the bracket and LED underscore data for subscribing the data. If the data is read from the cloud successfully using MQTT, then we will get a success code 500 as a return. The last data point in the LED feed can be read using char star LED underscore data dot last read. You can see the same in the code. Once the data is received, we need to convert it to integer from ASCII using the function a to I. After converting the data, we can use simple if else for switching on and off the LED. And don't forget to give the 2000 milliseconds delay there. It's very important too. IFTTT is a unique service where you can link any two services like mail, cloud, food delivery apps, Google Assistant and lot more with just few clicks. You only need few lines of code to control any appliance anywhere from the world using Node MCU and IFTTT. And LED is controlled using Google Assistant as an example in this tutorial to enable you to understand how powerful IFTTT is all about. You can extend the same to many real-time applications and moreover, you can integrate automatic mailing systems using IFTTT as well. In this tutorial, you will clearly understand how do we use IFTTT and Google Assistant together to perform voice control for electrical equipment. We can clearly use IFTTT along with Google Assistant with some coding skills to control any electric equipment as we are going to show you in this demo. This is very simple and easy to use and one can follow the entire procedure and they can do it themselves. Let's start the process. Again, I'm repeating it. We are going to use IFTTT, which is called if this then that, along with Google Assistant to control any electrical equipment of your choice. Let's go ahead and start doing the process. We need to first find out the link for IFTTT and that's what I'm going to do right now. Take any browser of your choice and go to Google, type IFTTT. Once it is typed, the first link will appear and that's the official IFTTT link. We are going to take it up and we will navigate there quickly. The moment we go there, the usage is all very simple and we can sign in if we already have an account. If not, we need to sign up. Since it is the first time that we are going to do, we may have to sign up. If you are doing it for the second time, you can sign in with your username and the password. Let's click sign up and you can sign up with Apple, Google or with Facebook accounts. It's very easy to use and it's very fast as well. I prefer to go with Google and that's what I'm going to do right now. I'm continuing to IFTTT and I need to give permissions for the same. So I'm typing my Gmail ID and I need to give my password for enabling the permissions and the access. This will enable Google and IFTTT to talk to each other without any issues. So this is done and the next step is to go ahead and type the username and password for logging in into IFTTT. The previous one is for the permission and the current one is to get into IFTTT. So make sure you understand this difference clearly. Now I've typed my password. Now I'm getting in. It is very easy and very simple process one needs to follow to get all these implemented. Now you can see that there is something called as applets which is made available in front of you. We do not have any applet created as of now from our side. We have a default applet available in front of you and it is called applet. Click on create applet and you will get this screen in front of you. If this, then that. You've got an add button over there that tells you the story. I'm going to click this add button, and if this means if you are going to create a trigger, if this trigger is going to happen. So I'm typing Google there and I have chosen Google Assistant. When you get into Google Assistant, you can see that you've got variety of options. You can say a simple phrase, you can say a simple phrase with a number, simple phrase with a text ingredient, both number and text ingredient you can use. As we are doing a simple application, we can use say a simple phrase option. We are going to use Google Assistant for the entire process and hence is the explanation. And the moment you do that, you will be connected and it might take few seconds for you to get this task accomplished. Let's wait until then. For the first time, normally it takes a little bit of time, but when the next time you do, it is always faster. Now we have chosen the account to be connected. We have already linked it and we are going to click the same account right now. Now it is requesting you to permit and allow all the transactions that we are going to do with the account. Allow is done. Now we are going to say a simple phrase and what do you want to say is the question. Now remember, we are going to say this into our Google Assistant and we will get the process done. Switch on LED is what we want to say. We also have another way to say it, light up LED, and there is third way to say it, on LED. And when we say this, the Google Assistant in turn should respond. So switching on LED is what it will say. And the language is English and we have created a trigger. We have created a trigger. The trigger is what if is all about. If this trigger is happening, then something has to happen. Now we have clicked that. Before creating the Adafruit action, we need to create an Adafruit feed. So let's open Adafruit in another tab and click Adafruit Industries, the website www.adafruit.com. Once you click that, it is all easy and we have explained you the usage of Adafruit in previous sessions as well. So we are going to follow the same set of guidelines. The first thing that we need to do is we need to go into IO option there, io.adafruit.com, and we need to sign in. We have already given you the procedure for creating the link with Adafruit for logging in. So follow the same procedure and get the username and the password created and sign in now. You need not sign up again and again. We can use the same method. Now we have signed in. It may take few seconds for you to load it. Now we need to go to feeds. We are viewing all the available feeds and PAR data is the only feed available there. This has been used for my previous exercise. Now we are going to create a new feed. The name of the new feed is LED and the description is optional. If you want, you can give, otherwise ignore it. Switching on and off. This is the description that I have given, switching on and off LED, and we have created a feed. Now this is the feed where the data will come when the LED gets switched on and off. Now we have got a feed created. Getting back to IFTTT, click on that Adafruit choose a service option. Send data to Adafruit IO is available there. This action will send data to a feed as we discussed already. Now click connect. The moment you click connect, it may take few seconds again for you to get connected to the account. Now you can see that you are connected to your Adafruit account, but we need to authorize it. Click authorize. Once it is authorized, that's all. The process is almost done. It's very simple and easy to use. Now you can see that the feeds that are available in our Adafruit are PAR, data and LED. I chose LED. Now what is the data that you want to save every time? When there is an action, some data has to go to the Adafruit and one is the data to be saved. Now creating action is done. Now if I say a simple phrase, then send data to Adafruit IO. If and then has happened. Now we need to finish it off and we can choose to receive notification when the applet runs or we can switch it off. That's up to you. Now we are finishing it off. If you say switch on LED, then data will be sent to LED field. That's what we have done right now, and we are finishing it off. It is very easy to use, and you can see that it is connected. You need to ensure that the entire process is followed properly and click got it, and that's it. It is connected, and we have created an applet, and this applet will be helpful for us to say switch on LED through our Google feed, and immediately the data would be sent to Adafruit Cloud. In IFTTT free account, we cannot switch off and switch on LED using one applet. Hence, we have to create another applet for switching off the LED. Now, I'm clicking that again. I'm going to Google Assistant. I'm going to simple phrase. What do you want to say? That's the option that we have in the beginning. Now we are going to say switch off LED. We have switched it on. Now it is duty to switch off also. So we are going to switch it off. We can also say it as light off LED. Off LED is another option. And the Google Assistant will in turn say that switching off LED. And language is English, and don't change it. This is a trigger. Last time we switched it on through the Google Assistant. This time we are going to switch it off. Select the same Adafruit. This is the action. We are going to get the action done for the trigger. Let's go to the feed name. We already have a feed created, and in that feed we can now give the data as 0. 1 for switching on and 0 for switching off. That's all. It is very simple. Now we need to continue and finish it off. You can prefer to receive notifications or not. That's up to you. Now we are finishing it off. Once finished, it is all done. We have got the trigger and the respective action created. Switch off LED will send data 0 to the feed. You are saying this to Google Assistant, and in turn you get the data in IFTTT. Now you can see that you've got switch on LED and switch off LED both available as applets. Now you will get data every time here in this Adafruit, and you can see that during the demo. And make sure you copy the IO username and IO key properly and replace it in the code. This is very important for you to run it. Make sure you enter the IO username and key as mentioned in the Adafruit page itself, and give the right key for you to run the process smooth. Also update the username for the Wi-Fi and password for the Wi-Fi appropriately for you to get connected. The code is very simple and it can be understood with ease. Now make sure that you are selecting the right microcontroller as well as the right COM port. If it is not selected, again we may have some issues over there. That's all. We can compile it right now, and that's what I'm doing right now. Once the compilation is done, it can be uploaded, and it takes few seconds for you to complete all this process. Once it is done, we can go ahead and start the process. You could see that the LED is connected to Node MCU. Use a phone in which same Google account given for IFTTT is logged in. We can open the serial monitor to parallelly visualize what is happening. Now I'm going to call the Google Assistant, and I'm going to use the Google Assistant with the phrase that I have already given in the code. Switch on LED.
Switching on LED.
You can see that the LED is on and the data received is also shown in the serial monitor. LED is switched on. The message is available. Switch off LED.
Switching off LED.
Now you can see that the data received is 0 and the LED is switched off. We have used another terminology also. We can call it by another way. So we are going to say as on LED.
Switching on LED.
And immediately you have received the data for on LED. So the LED is also on. This is how you can use IFTTT to switch on and off the LED through voice with the help of Google Assistant.
So I hope you guys enjoyed the complete practical demonstration of how voice-based systems can be built with IFTTT. Was it interesting? Can I have thumbs up, thumbs down, some reaction? I want people to be very active. So thanks, Ravi. Um, so you have any questions, you can ask it at the end of it, or if it is so urgent, I can answer it right now. Mr. Manigandan and Gopalakrishnan. Go ahead, Manigandan, first, if you have any question. Manigandan, do you have any question? Gopalakrishnan, I think you raised hands. Um, Okay, if you have nothing, that's fine. So just to keep you in real sync, I'll show you something that I have built for Honda, right? So Honda, it's a majestic company with respect to automobiles. So I have built this for Honda, and we have won the second prize in the Honda Global Hackathon with this innovation. All these are built in-house. You do not have to really spend a lot of money, effort, time, everything for building these kind of stuff. All these are built in-house. I'm going to walk you through that right now. Just have a look at it. This can be implemented in your low-end car. If you have Maruti 800 or Alto or WagonR, I have an WagonR. So I built this for my WagonR car because it doesn't have so much of security features. I built this on. So if you have a low-end tier car, which is not so feature rich, you can use this there. All these are built within an expense of about 10,000 rupees. Just have a look at it. You'll be stunned to watch. I'm sure you will like it. Once this is done, I'll go back to the regular flow.
We are going to see the complete demonstration right here. The first module is driver authentication, and we have trained the system with one of the phases. The demo is here.
You are authorized. Dash. Drive safe.
We can drive the vehicle now. Now we are going to show the image of a child as such it is sitting alongside the driver.
Children are not allowed in the front row. Children are not allowed in the front row.
This is absolutely prohibited in many countries and we follow that.
Children are not allowed in the front row. Children are not allowed in the front row.
In case of an accident, the children could suffer more than normal people. So we alerted. We are going to see if we can overload more number of people into the car, and we are going with that scenario testing right now.
Passengers limit exceeded. Passengers limit exceeded.
We are getting that alert as well real time, identifying the male female as well perfectly there.
You are authorized. Dash. Drive safe.
The driver can wear a spectacle, the driver can wear a cap.
You are authorized. Dash. Drive safe.
You'll be recognized. Now we are going to the next part of it where we are going to
Sir?
check the driver is drinking, smoking,
Sriram,
or
sir.
he is using mobile. That's what we are going to
Yes,
do
ma'am.
right now, and we will
In
check
chat
if
box,
things are working proper.
Dr. Manigandan
Let's
asked
first
one query,
go
sir.
ahead and start checking with.
I'll answer that one. Let's watch this.
Do not
Okay,
use
sir.
phone while driving. Do not use phone while driving.
Now drinking.
Do not drink while driving. Do not drink while driving.
Now what's left out? We need to check if we can smoke while driving.
Do not smoke while driving. Do not smoke while driving.
We can detect if the driver is about to sleep as well, and we will alert.
Do not sleep. Do not sleep.
As you can see, this is all real time and absolutely working fine. Now we are going to assess the drivers. You can see that the entire system is working fine, and we will give an alert if you are going close to the previous car. The dangerous message comes and we track it real time, and we will keep you in a safe distance with a voice alert.
Dangerous.
We are also capable of detecting the lane change, and we are going to do that right now.
Lane change alert.
You could see that we are alerting it. Now this is for Indian scenarios. You could see that there are intruders.
Dangerous. Slow down.
We have detected them properly. And this is tested with Indian dataset, and that is the most challenging part of the entire product. You could see that there are races on the road.
Dangerous. Slow down.
And we are able to alert the driver properly. You could see that it's all working.
Sorry, something went wrong. Just give me a second. some internet connectivity issue. Just a second.
We are going to see the complete. We can detect if the driver is about to sleep as well, and we will alert.
Do not sleep. Do not sleep.
As you can see, this is all real time and absolutely working fine. Now we are going to assess the drivers. You can see that the entire system is working fine, and we will give an alert if you are going close to the previous
Dangerous.
car. The dangerous message comes and we track it real time, and we will keep you in a safe distance with a voice alert.
Dangerous.
We are also capable of detecting the lane change, and we are going to do that right now.
Lane change alert.
You could see that we are alerting it. Now this is for Indian scenarios. You could see that there are intruders.
Dangerous. Slow down.
We have detected them properly. And this is tested with Indian dataset, and that is the most challenging part of the entire product. You could see that there are races on the road.
Dangerous. Slow down.
And we are able to alert the driver properly. You could see that it's all working perfectly fine for all the scenarios. We are going for the next scenario right now.
Dangerous. Slow down.
You could see the way he is racing, and we are able to detect that as well. Now we are going to detect animals.
Dangerous. Slow down. Slow down.
You could see that animal intrusion is detected. Night drive. We are supporting the night.
Dangerous. Slow down.
So all these are real time, absolutely voice-based support is
Dangerous. Slow down.
and is working fine. And this is tested for stability, and it's working functionally very fine for all the scenarios. Now we are providing a virtual bumper. As you can see, when you go closer,
Dangerous.
you get a virtual bumper, and there will be a
Car started.
and car starter alert is also coming. The previous car, when it moves, if there is somebody who can tell you that the car has moved, you can move. That's going to be great. We provide you that facility. Now the blockchain part is coming in. You can scan the status of your car. I mean, you can scan the health status of your car with a single click. That's what we are going to do. We are launching our app, and we get all the data from the sensors, and we push it onto the blockchain so that it gets non-tamperable. If you know the vehicle number, type the vehicle number. You get all the data in front of you about the vehicle's quality, and you can get it in seconds. So I've typed that, and you can see that. This is just a tentative data. We moved it to the blockchain, and we used Hyperledger. You could see that we have just tentatively prepared it because Honda has provided a lot of data. From that, we understood that these can be some of the data that can really go into the blockchain. And if you do not know the number of the vehicle, and if you are really a little lazy about it, scan the QR code. You get the data immediately in front of you. We have given a specific QR code for all the cars, and you could get the data immediately. And all these are real time, and this is working fine. And once it goes to blockchain, as you know, it is never tamperable, and we are testing it with one more scenario, and that's also giving you absolute data. So overall, we provide a system that can help the driver, that can monitor the driver, and that can keep you safe. We thank you for the opportunity that you have provided, and we look forward to hearing from you the feedback. Thank you.
How was it, friends? Did you like it? This is all simple, doable at home. You do not require any high-end systems or great speeds. All those are not required. Just hard work is sufficient. And learn a little bit of machine learning and deep learning, you will be able to handle this. Did you like it? I need thumbs up, thumbs down, good, bad, ugly. Let's keep it interactive. Did you like it, guys? Nobody reacts. Very difficult to understand people. Thanks, Gopal. Thanks, Kishorji. All right, we'll get into the next one. When vehicles meet with fire, there can be fire alarm. Easily, the fire alarm can be detected these days. The fire alarm can be detected with ease. How do we get it done? How do we detect fire alarm? How we can make it nice? All those things are going to be shown right now along with demo. With a disclaimer, don't try it at home. You cannot try it at home. You have to be careful when you try it. So try it at lab, that is better.
After listening to this session, you will be able to understand how fire alarms work, how to make a fire alarm at home, and how do we add the call and the SMS alerts to the system. All this will be clearly understood, and it's going to be an interesting session. Fire alarm with SMS alerts. How fire alarms work? Fire alarms have been made mandatory devices in every office, public places, etc. It is very important to detect if there is any fire in any part of the buildings and to prevent it. Fire alarms can detect fire. They are installed on the ceilings to detect smoke because smoke is lighter and rises up. Generally, fire alarms are of two types, which are as following. Ionization smoke alarms. They contain a small amount of radioactive material that passes between two electrically charged plates, and if the smoke enters that space, it absorbs alpha particles and disturbs the ionization process, which reduces the current and activates the alarm. The second type is photoelectric smoke alarms. The photoelectric alarms work using a photoelectric sensor and a light source. As smoke enters the chamber and crosses the path of the light beam, the light is scattered by the smoke particles aiming towards the sensor, which in turn triggers the alarm. How to make one at the home? You might be wondering, why are we again talking about making a fire alarm besides having one already installed? It's because they are not smart and they aren't connected. This course is all about making it smart and connected, and that's why we build once again. In this session, we will be building a smart fire alarm system with sensors and also an alerting system which will alert us through an SMS. We will be using MQ05 sensor, LM35 temperature sensor, Node MCU and GSM unit to accomplish the task. You can see the pictorial representation with animation that we have presented in front of us, and it will be helping us to understand the whole scenario. When there is a smoke detected, we will get you alert, and all this happen real time. Hardware connections. You can see the table which is presented in front of you, also the schematic in front of you for you to understand how exactly the connections are to be made. We will be using MQ135 LM35 sensors for detecting gas leak and temperature. The Node MCU processes the data from these sensors and makes a call using the GSM SIM 900A. You can see that in the table we are connecting 3.3 volt of Node MCU with MQ135 VCC and LM35 VCC. The same has been projected in the pictorial representation where the connections are presented. The ground of everything is connected appropriately together. The D5 pin of Node MCU is connected with MQ135's D0. A0 pin of Node MCU is connected to out of LM35. D8 is connected to SIM 900A's TX, and D7 of Node MCU is connected to RX of SIM 900A. And all these have been clearly represented here in this diagrammatic representation which presents the circuit connections. It's time to code. D8 and D7 pins of Node MCU are used as RX and TX for communicating with the GSM. D5 pin is used for getting the MQ135 data and the A0. It is the only analog pin of Node MCU, and we need to remember it. The A0 is used for getting the temperature data from LM35. MQ135 underscore data and LM35 underscore data are used for storing the data from the sensors. We have to set the resolution of LM35 appropriately to get the correct temperature readings. Resolution can be represented by the formula Vref by 2 to the power of n minus 1, where Vref is nothing but the voltage to which the Vref pin of LM35 is connected to, and Node MCU uses 10-bit microcontroller, then 2 to the power of n is nothing but 1024. We need to remember these points, and the same has been presented in the code. One can walk through the code easily to understand the concepts. We have used two serials, one for writing on GSM serial and another one for writing onto the Node MCU's serial. Yes, it is very simple, and the code is presented in front of you for your easier reference. MQ135 and LM35 pins both are set to input mode as we are taking the data from these sensors as input. You can see the same from the code where we have set MQ135 and LM35 both as input. When the MQ135 detects gas is being leaked, then the sensor outputs 0, or else it will always remain 1. we mean to say that the leakage will be detected and the action will be initiated accordingly. The data from the LM35 is multiplied with the resolution into 100 for converting it into centigrade. If any gas leak is detected or if the temperature crosses 60 degrees centigrade, then send message function will be executed. You can see the same thing in the code, and it is very easy to understand and is self-explanatory. Once the temperature crosses the 60-degree threshold, you get an alert message saying alert, your house is on fire, and the same is coded, and that helps us in implementation. Send message function is used for making a call and sending a message when fire or gas leakage is detected. ATD plus 91 followed by the mobile number is used for making a call, and AT plus CMGS equal to plus 91 followed by the number is used for sending a message. The X should be appropriately replaced by your phone number. The same has been presented in front of you as a code snippet. Just replace wherever X is there with your phone number so that you would get the call and the message as required. Try this out, folks. In this session, we have shown how exactly to create and build a fire alarm in the home using Node MCU, MQ135, LM35 and GSM. As we are using Node MCU, by now there could be a query in your mind that why are we not using cloud for uploading data? So as an extension for this exercise, we want you to try sending data to the cloud when you detect the gas or fire leakage. That's the next step, and it's easy to do as well. We need to create a feed when the gas leakage is detected, when the fire is detected, the data goes on there. In this tutorial, we are going to demonstrate how easily can someone build a fire alarm system for your home or for your office. It's a very simple process, and please follow the guidelines meticulously and you can build your own fire alarm at your office or at your home. The first step is to make sure that to choose the appropriate components, and we have got MQ135, LM35, and we have chosen Node MCU because it is very easy to use. Also, we have got the SIM900A, which is the GSM module. We have integrated all the three of them properly with proper connections, and that's very important. You are seeing the MQ135 in front of you, which is an air quality monitoring sensor which can detect the presence of various gases including the LPG. So we are going to use the feature of this LPG detection and we are going to get things done. When you turn it upside down, you get most of the details understood clearly. There is a power LED which shows that it is powered up. There is a potentiometer which is available for sensitivity adjustment, and we have adjusted it appropriately to get the correct output. And there is something called as D0 LED which we are pointing right now. What is it? It is an LPG indicator. When LPG is detected, LPG leakage is detected, this LED gets glowing and it is an intimation for you that the LPG is present in the environment, and that can be referred during the demo as well. Now, the next step is to understand how do we get the implementation done. Once the wiring is all done, once the connection diagrams are all done, you can run the code which we have presented to you during the tutorial. You can see that we need to change the phone numbers in the XXXX place appropriately, and once it is done, you can upload the code and you can see the demo. And please change it for the message as well as call as we are doing right in front of you. Then once it is done, you can also see that there is a message that we are printing called emergency, your house is under risk. That is the message that we will get. Please validate if appropriate boards and appropriate COM ports are selected. That's very important, as every time we say. So once it is all done, you can go for compilation. You can see that the compilation is successful and then uploading will happen. But it is not uploaded. Can you watch it? The upload is not complete. Why? There is a reason and we need to learn it. As we kept on telling you right in the beginning, also in the previous set of courses, that we are connecting the RX and TX of GSM to Node MCU. So this won't enable you to get the uploading done. So when you want to upload it, please remove the connections and then try uploading. And once the uploading is done, you can connect it back so that the entire process is smooth. That's what we are going to do right now. We are going to remove the RX and TX. Even when you are using the software serial library, it won't work. So you remove it, upload it, and then connect it again. That's what we have done, and then uploading message has come. Now we can go ahead with the demo part of it to understand how exactly the system works. We can see the reading that comes out from the LM35 temperature sensor, and now I'm going to get the LPG's presence in the environment, and it will be detected by the LPG sensor. You can see that immediately the D0 LED is glowing to tell you that it is LPG which is made available right there in the environment. That is an intimation, and you got an alert LPG gas is leaking at your home. Immediately there should be a call as well, and you are seeing it in front of you in the phone. So also we will get a message. So we made LPG's presence through using a lighter, and we got an alert call. We will also get an alert SMS, and that will be shown to you as well. And all these are done real time. The message has come, and you can see that emergency, your house is at risk. That's done. And please be careful when you try it at your home or at your office, as it has a risk of catching fire. You need to do it carefully. Now we are getting into the second part of it, where we will see if the temperature sensor is going to get us alert when the temperature inside the home is increasing. We are going to use the same lighter, but we are going to increase the temperature. We are going to use the lighter for a little longer time, and the sensor will detect it. Please do it carefully again, as it could hurt you. You can see that the temperature sensor is given more temperature so that it can detect it, and the temperature is increasing till 60, alert, the threshold is reached, and your house is on fire. So we got a message. Once the threshold is reached, we get the alert call as well as we get the alert message. Can we see that right now? Yes. It's very important to understand and see the way it is working. We got a call. We must have got an SMS as well, and that will be shown to you right now. Let's go ahead and wait for SMS. It will come maybe in 20 seconds, 30 seconds maximum based on your network connectivity. And yes, we got it. Emergency, your house is under risk of fire or LPG. So we got the alert, and all these have been implemented real time with a very simple setup. One request to you is, please try it out carefully at home. It has the risk of catching fire. Let's summarize. Fire alarm can be made smart using IoT and cutting-edge technologies like cost-efficient microcontrollers and affordable sensors. This session is a hands-on session where we have developed a very simple fire alarm system in less than 30 minutes from the scratch. You can improve the same application by replacing GSM with cloud services. This will make the prototype size smaller and even more affordable. GSM is useful in sending immediate alert in case of the power cut or situations where the network is very low. MQ135 sensor cannot detect LPG gas, as well as the lighter which is used in the video does not contain any LPG in it. The lighter contains butane, and MQ135 detected it. Only for your easier understanding, we have mentioned LPG gas throughout this video.
How was that? Did you like it? Was the demo understandable? I need yes, no,
Yes,
good,
sir.
bad, agree.
Yes, sir. Yes, sir.
Yeah, perfect. So we'll go with one more. Next 15 minutes, you should listen to me. I'm going to show you how we can build a logistic tracker nicely. Logistics, shipping from Amazon is happening, right? They ship from one place to another, and how do we track it? I'm going to show you that nicely. It's going to be the same sort of demo like this. You will enjoy. Just have a look at it.
To the session, you will get a clear understanding about how GPS works, how do we make a logistics tracker application, interfacing GPS sensor with NodeMCU, and uploading the GPS data to the Adafruit cloud. Logistics tracker using NodeMCU and GPS. How GPS works. Let's understand that first. GPS is an acronym for Global Positioning System. It was first developed by the United States Navy in 1960 and later made public for all kinds of applications. The GPS uses a method called as triangulation, as shown in the picture which is presented to you. 3 satellites simultaneously work to get the location, velocity of a GPS receiver. Today, 24 GPS satellites are there in the space constantly working to provide us with the GPS information. The data from these satellites are transmitted in NMEA format, which is the standard protocol for GPS information. In today's session, let us understand how this data can be acquired and processed to get your present location and how do we upload them to the cloud, making a logistics tracker. Every order we purchase on e-commerce sites like Amazon, Flipkart, etc. comes with a live package tracking feature. It will be updated manually at the distribution centers but is not a reliable process in the complex logistics operation. In this session, we will build a simple logistics tracker with u-blox GPS sensor, Node MCU and Adafruit Cloud. Yes, it is really simple. We are getting you a pictorial representation and it helps you in understanding the total process. In the origin, in the transit, in the destination, we track the location and we get you everything real time. Interfacing GPS to Node MCU. u-blox is a Swiss company that creates wireless semiconductors and modules for consumer, automotive and industrial markets. Neo 6M GPS is their GPS transceiver module which can be interfaced easily with any of the microcontrollers. You can make the connections with reference to the picture that we have presented, which explains the connections. Their table is presented for your easier understanding, and the Node MCU's 3.3 volt pin should be connected to VCC of GPS, ground should be connected to ground, D7 of Node MCU should be connected to TX, D8 should be connected to RX. The same has been presented in the picture as well, which represents the circuit diagram. Installing GPS libraries in Arduino IDE. The data from the GPS sensor comes in NMEA format, which has a lot of data apart from latitude and longitude data. But we need only lat and longitude to know the exact location. The NMEA data looks as shown in the image that is presented to you right in front, and the $GPRMC line is needed for getting the location data. It is a tedious task really to parse all this data, hence we will be using tiny GPS++ library to directly parse this data and to get the location details. It's the smartest way to get this done. The .zip file of the library is provided in the resources, or you can go ahead to the GitHub link that is presented in front of you for downloading the tiny GPS++ library. You can download it and you can follow the procedure as we are explaining you right now. Once downloaded, you can go to the sketch and include library, and in that you've got add .zip library option as the pointer is showing you right now. And click on add .zip library option and choose the path where you have the downloaded library files available with you. Configuring feeds in the Adafruit Cloud. You need to create a new Adafruit feed for uploading the lat and long data. Create a feed named location in the Adafruit IO. This feed will be used to store all the data sent from Node MCU. You can see the snapshots which are presented where we can create the feed taking these guidelines. Here we are creating a new feed by the name location, and description is optional again. We are giving used for storing location data. So once the feed is all created, we are all set to go. Publishing GPS data. Once the connections are made, we need to code the Node MCU to read the GPS data and to publish it to the Adafruit Cloud. We have used tiny GPS++ library for getting the location data from the NMEA data. ESP8266 Wi-Fi for connecting to the internet, and Adafruit_MQTT_client libraries for publishing the data to the Adafruit Cloud. And the same has been presented in the code right in front of you. A variable GPS of tiny GPS plus class is created for parsing the NMEA data into the location data. GPS serial is used for communication between the GPS and the Node MCU. The D7, D8 pins of Node MCU are used as the RX and TX for receiving the GPS data. lat_str, lng_str, loc_str are used for storing the location data appropriately. And the same has been presented in the code right in front of you. A variable named ESP of Wi-Fi client class is created for helping in MQTT connection. Another variable named feed of Adafruit underscore MQTT underscore publish class is created for publishing the data to the Adafruit feeds. And the same has been represented in the pictorial representation with a pointer pointing to it appropriately. Serial of node MCU is set at the baud rate of 115200 and the GPS serial is set at the baud rate of 9600. The remaining code in the void setup is used for connecting to the Wi-Fi and then to MQTT. It is similar as we have learned in the past. And it's a very simple code and we request you to go through it. Char location is used for converting the location data into character array before uploading to the Adafruit cloud. And this is a mandatory step. When there is an incoming data in GPS serial, which is GPS serial dot available greater than 0, then the data is read and encoded to the tiny GPS plus class format. This is important and in fact to be followed meticulously. If the location in the GPS serial is valid, then it gets uploaded to the Adafruit cloud to the location feed. And the same has been represented in the code. You can see that here, if GPS serial dot available has got a valid data, it gets into the further code and we get the lat, long and the location obtained in, and further process goes on. In this session, we have shown you building a logistics tracker and how to upload the data onto the cloud. Instead, we want you to try to build a web page and host it on NodeMCU and show the location data on the web page. This is a challenge and we hope you definitely do it. You can build a web page by using your knowledge of intermediate courses. Don't worry if you are having any trouble or challenge in the middle. We have provided the code for logistics tracker using web page in the resources itself. And the screenshot is presented to you to motivate you. This is already done and we want you to try it once by yourself. The summary. In this session, we have moved a little bit far and made an application to track packages real time throughout the transit. To make this application, we have utilized the GPS sensor to acquire the location and uploaded it to the Adafruit cloud to make the data accessible anywhere from the world. You can also use a LoRa communication for this application, which makes it easier by eliminating the edge processing and cloud updation. Let's go ahead with the demo right now. We are going to visualize how exactly the NMEA data looks like. But before that, you must be having a couple of queries in your mind. The first question would be like how the GPS module or what exactly the GPS module returns when it is connected to satellite and when it is not connected to satellite. We have a workaround here and we are going to get you a clear understanding on this, and then we will go to the demo part for the logistics tracker. You can see that we have connected our GPS module to the TTL dongle with VCC to 5 volt and ground to ground, RX to TX and TX to RX, and then it's connected to the laptop. Now let's go ahead and open the TerraTem. Once the TerraTem is open, select the appropriate serial, click OK. Once it is done, you are all set to go. You can see that there is some data which is coming in front of you and it is called NMEA data and no location information is available. You cannot spot any location information available here, and this is when it is not connected to the satellite. When it is connected to satellite, the data feed would be different and it will have the location information. Now it's not connected. We are going to get it connected right now. The connection will be understood with the red indication that you have got right now on the GPS. You can see that we have got the location data made available right in the result, and that's because the GPS is connected to the satellite. And this is how you get the location statistics and the data from the GPS. Let's understand how exactly the logistics tracker can be built. Now we have used a node MCU and it is connected to the GPS sensor. We have already explained you how exactly to use the GPS sensor, and the connection diagrams have been given to you in the theoretical explanation. Please make sure all the connections are appropriately given, and this is nothing but the antenna that you are seeing in front of you. Once the satellite is connected or the GPS is connected to the satellite, we get everything easy, and this feed is going to go to the Adafruit. And please make sure that the red LED indication is on to let you know that the U-Block's GPS sensor is connected to the satellite. Go to Google and type Adafruit IO. This is where we are going to upload our GPS data that we are receiving. I have already got an account created, so I am going to sign in. I am signing in with my username and the password. So once it is all done, it's all easy for us to go ahead. I am signing in right now, and the next step is simple. We need to create a feed. Yes, we will have to go to feeds. View all will let you view the available feeds, and we are going to create a new feed. The feed name is location, and description can be given as per your wish. Here we are giving used for storing location data. Once it is done, it is created and the work is almost done. You've got the location feed available, and currently there is no feed in because we have not yet executed. Let's open the Adafruit IO key tab, and you can see that we have got the username and the IO key copied, and this has to be pasted appropriately in the code that we have written to get it connected appropriately to the cloud. And here I need to give my Wi-Fi username and the password. Once the username and the password is given, we are all set to compile the code and run it. We are going to do that right now, and the code has to be saved. We have done the saving right now, and please make sure you have selected the appropriate board and the appropriate COM port is enabled for the process to be complete. Now the compilation is all done and it's getting uploaded. You can see that. Now the most important point to remember right now is the GPS sensor will not give you correct output when you are keeping it in-house. So please remove the power source, the USB cable out of the laptop, and connect it to an external power source, that is your power bank. And when you take it outside, you can get the GPS feed right now, and the feed will be updated in the Adafruit cloud. Now this is because the closed space connections does not work with GPS, and you will not get data when you are working in the closed space. That's the reason we have removed the power source and given it a new power supply through our power bank. And when you take it outside and keep it away from the in-house setup, you will get the GPS coordinates, and that's what you are seeing in front of you. We have taken it out, and the red LED blinking is showing that it is connected to the satellite, and all the data updates are getting into the Adafruit feed. And that is it. The process is very simple, and remember the procedure that we have given you, and you can repeat the same at your place as well. This is very easy exercise, and it can be done to track the logistics or to track anything with ease. Now, what we are going to do is we are going to take one of these feeds and we are going to test it if the location is all right. I'm doing it from Hyderabad, from my home, and I'm going to see if we are getting the same location identified with the Google Maps. I'm going to copy paste the location coordinates from the Adafruit, and I'm going to the Google Maps right now, and I'm pasting it in the Google Maps to identify the location. Now you can see that it's exactly the address that I'm sitting at, and I'm making this video. That is it. You can track anything that you want with this kind of setup, and the node MCU being connected to it with ease, and the data has gone to the cloud for you to get it tracked from anywhere in the world.
I hope you guys enjoyed the session. I'm really thankful for the opportunity. If you have any questions, you can ask me now. But otherwise, I'm done with it. You guys enjoyed the session? Can I have thumbs up, thumbs down, good, bad, agree? Great. Thank you. If you have any question, please go ahead. I've already given you my LinkedIn detail and the channel details. You can subscribe. There are thousands of technical videos like this.